science fair is called Electromagnetic Exploration.
Our question is if the gauge of a wire would affect the electromagnetic strength. Our hypothesis for the question is if the gauge of the wire is thicker, then the 18-gauge wire electromagnetic strength would be greater than gauges 22 and 28. The independent variable in our experiment is the gauge of the wire, the dependent variable is the power of the circuit, and the controlled variables are the length of the wire when it's wrapped around the nail, D batteries, the insulated wires we use to connect to the battery holders, and sandpaper.
For the background research, we explained how to make an electromagnet as well as how an electromagnet functions. In our explanation, we discussed how magnetic fields are made, what electric coils are, and how they're made, replacement for the nail as well as the remaining step to building an electromagnet. Additionally, we also talked about why D batteries are a better option than size batteries like AA, AAA, and C batteries, as well as why the nail an electromagnet tends to heat up. By using D batteries, the magnetic field will be stronger because the current of the battery is a lot bigger compared to the other common-sized batteries. The nail tends to heat up an electromagnet because of the movements in electrons.
The materials we are using for our experiment include paper clips, 6 D batteries, sandpaper, a nail, insulated wires with an estimate of gauges 18 and 10, 3 gauges of wire, 18, 22, and 28, and 2 battery holders.
To prepare for the experiment, you'll need to add a battery in each battery holder. Then you'll connect the batteries using insulated wires. After that, wrap the nail until it's 4.8 centimeters long, leaving 3 centimeters on each end. Next, you'll need to sand the ends of the wire. Once done, you'll attach the clips on each end of the wire. Afterwards, you'll need to place the circuit on a higher surface. After waiting for a few seconds, unfold one end of the paperclip. Attach the paperclip onto the nail. Slowly add paperclips onto the nail one at a time. Once you've added 18 paperclips onto the folded paperclip, you need to get another paperclip. Then unfold one side of the paperclip. Next, attach the unfolded paperclip onto 1, 2, 3 paperclips. From there, continue adding paperclips and repeat step 10 and 11 until the paperclips fall. Count the amount of paperclips once it has fallen.
Some things we noticed in our experiment is that the gauge 18 wire held the same amount of paperclips with all 3 trials, and the 22 gauge wire held less paperclips than the gauge 28 wire.
This is the data table and graph we created from conducting our experiment. These are some pictures and videos demonstrating the steps from the procedure slides.
The first and second clip demonstrates how to add their paperclips, and the third clip shows the paperclips falling. The average of the 22 gauge wire is 30.33 repeating, the average of the 18 gauge wire is 41, and the average of the 28 gauge wire is 36.66 repeating.
We accept our hypothesis because the strongest electromagnet was created by the 18 gauge wire. Our question is, does the gauge of the wire affect the electromagnet strength? To conduct our experiment, we wrapped a wire around the nail and connected the nail to a circuit. To test our hypothesis, we added paperclips to the nail until all the paperclips fell. We then repeated the experiment with 3 different wire gauges. Our hypothesis was correct. The 18 gauge wire produced a stronger electromagnet than the gauge 22 and 28 wires. However, we were confused about some of the results in the experiment. The electromagnet produced by the gauge 18 wire held the most paperclips. Despite being the smallest gauge 28 wire didn't hold the least amount of paperclips.
Some things we noticed in our experiment is that the head of